Okay, looking at these, there's a fast way to do these, but I want to show you factoring by grouping as well, because you could do it either way and you can get the same answer. However, when you see the fast way to do these, you'll probably like that. It won't work for some of the others though. Looking at this, we know we don't have a middle term, so it would be the same thing as if I had 0x. Do you agree? Since there's no middle term. Based on that, we would draw our little x so that we can find our missing numbers. Take our first term, multiply it by our last, and we get -9. Then we take our middle term and we put it on the bottom. We're looking for two numbers that multiply to give us the top and combine to give us the bottom. Yes, sir?
+3 and -3.
Yep, I agree. So I got 3 and -3. 3 times -3 gives me -9. 3 minus 3 gives me 0. We're going to take those numbers and we're going to replace that middle term. So I'm going to have 9x squared plus 3x, don't forget your x, minus 3x minus 1. So now my plus 3x minus 3x replaced my 0x. Then we group, right? So we're going to group our first two terms and group our last two terms. Put a plus sign in between. Looking at our first two terms, what do they both have in common? What's the biggest thing?
3x.
3x. So I'm going to write my 3x and then I'm going to divide both of these by 3x. All we're doing is taking out the GCF, the greatest common factor, right? 9x squared divided by 3x, what would be left? 3x. 3x divided by 3x. 1. Remembering that these are going to have to be the same, there's no way I can leave that one alone over there. What do I have to factor out? -1. So I'll divide each one of these by -1. That's going to give me my 3x plus 1. These two must be the same for the factor of grouping to be correct. That is one of your factors. The other one is the stuff on the outside. Okay with that? Okay. Faster way. Notice all these scenarios, there's no middle term. There's no x. Okay? So should you have something, it's a difference. Difference. Is this a difference? Yeah, subtraction is a difference, right? Difference of squares. Does 81 have a square root? 9. Does x squared have a square root?
Yes.
Does 36 have a square root?
36.
Difference of squares. All those things are squared, right? If you have a difference of squares, all you have to do is put parentheses, put a plus and a minus, or a minus and a plus, it doesn't matter. Take the square root of the first term. Put it in the front of each of your parentheses. What's the square root of 81? 9. So 9x. Put that in the front of both of your parentheses. Take the square root of the back. What's the square root of 36?
6.
Put it in the back. Voila. So let's bounce back over here and think about that same idea. Parenthesis, parenthesis. What's the square root of 9x squared?
3x.
There you go. 3x plus minus. Square root of 1? 1. Yeah. So if you have a difference of squares, you can probably get there a whole lot quicker. Yes, ma'am?
So is it going to be like pretty much the same except the signs will be changed in the middle?
They're exactly the same, but one will be plus, one will be minus.
Like all the time?
Yes. If it's a difference of squares. And the reason is because if I go to multiply this out, I'll end up multiplying 9 times -6, right? Which gives me -54x. Positive 54x. What just happened to my middle term? It goes away, right? So this only works when you've got your difference of squares. Okay? We got another one down below. Parenthesis, plus, minus. What's the square root of the first term? Put it in the front. Square root of the last term?
3.
Put it in the back. Okay, so now you get a hiccup. Yes.
Does it matter what order this?
Nope.
Plus
I could put
minus
x
go?
minus 3, x plus 3, doesn't matter. This one's a hiccup. Does 3 have a square root? No, 75. At least not a pretty one, right? So what we're going to do at this point, if I see this type of thing and I see a minus sign, I still want to find out, is there possibility of difference of squares? What if I were to take the 3 out?
Just be x squared plus 15. No, not 15.
75 cents. How many quarters go into 75 cents?
It's
There you
like
go.
five, yeah.
So 25. Does 25 have a square root?
Oh,
Yes.
Yes, I just gave it to you. So now I could do my parentheses plus, minus. So I literally just had to take out the GCF and then I could use my difference of squares cheat. You could also use factoring by grouping. You'll still get to the exact same thing. Okay? This is just a little quicker. So we got a couple practice problems. Looking at this, the quadratic formula, anybody know the song? Anybody want to get up and sing the quadratic formula song? Yeah, they sing it to like row, row, row your boat.
Yeah.
YouTube it. It's out there. Okay, anyway, it goes x equals negative b plus or minus the square root b squared. I can hear it in my head when I say it. How do you feel? I don't teach the song, I just talk about it.
No, not just again.
So much.
When you look at the quadratic formula, a couple things to notice. X equals. In other words, when you use the quadratic formula, you're finding out where it crosses the x-axis. These are our roots, our solutions, okay? The other thing, this thing right here is called the discriminant. Do you see it somewhere in the quadratic formula?
Is it the b2 minus 4ac?
Yeah, it's underneath the radical, right? That's it right there.
This is it?
Yes, that's it. Flip it over. Ta-da! There you go. So, this stuff right here is what's inside of your radical. The discriminant will tell you if you're going to have one solution. Let's see, one solution would look like my vertex sits on the x-axis, right? Two solutions, which would be my parabola actually crosses it, or no solution. So our parabola floats up in space, never going to touch the x-axis, right? You can find that out from your discriminant. So let's see how it tells us all that stuff. Looking at this, standard form, we've learned this before, ax squared plus bx plus c. That's standard form, right? The x squared term, the x, and the constant. They need to be in that order. You need to make sure they're in that order before you start plugging in numbers. Looking at this, what's ABC? 2,
2x squared.
3, no x's, just numbers, and negative 4. So 2 is our A value, 3 is our B value. Make sure you keep your signs. So C is our negative 4. Okay. Then we talk about our discriminant is B squared minus 4AC. And all we're doing right now is determine how many times this particular graph is going to touch the x-axis. So looking at this, and this is the part where I'm going to do something, and y'all know me, I don't write anything more than I need to, right? So I'm going to put parentheses squared minus 4 parentheses parentheses. And y'all are going to like to do that because that's a lot of parentheses you have to write. You don't like to do that, but I'm doing it, which means I'm probably doing it for a reason. It matters. I'm just going to start plugging in my numbers. So B equals 3. Then I got A, which is 2, and I got C, which is negative 4. You can plug this into your handy-dandy calculator just like it's written, or 3 squared is what? 9. What's negative 4 times 2? Negative 8 times negative 4?
32.
So plus 32. What's 9 and 32?
41.
41. Is that positive, negative, or 0? Positive, right? So our B squared minus 4AC is greater than 0. It's a positive number, which means you're going to have 2 real solutions. This would be a scenario where your graph will cross it, like so. Oh, I got another spot. 2. Looking at the next one, what's our ABC?
1, -4, 5.
1, -4, 5. This time I don't have to write all my b squared stuff again. I'm just going to put parentheses squared minus 4ac. Plug in each one of your letters. So b is negative 4, a is 1, c is 5. This is why the parentheses are important. Negative 4, let me rephrase, negative 4 squared is negative 16. But negative 4 squared is positive 16. Without the parentheses, you're going to get a negative 16 for that answer, which would be incorrect. This is actually going to be 16. One of the reasons the parentheses matter. Negative 4 times negative 4 is positive 16. Okay? If you write this down real quick and you plug it straight into your calculator and you use parentheses, you're going to get the wrong answer if there's negatives involved. Next, I got negative 4 times 1, which is times 5. So we end up with 16 minus 20, which is, let's see, we got negative or 0 left. So which one's this one? Negative. If you get a negative number, oh, let's do that in your calculator. What's the square root of negative 4? Is it like negative 2 or something? Put it in your calculator, see what you get.
You can't do it.
What does it say?
It says it's not a real calculation.
It says non-real solutions. So, calculations, I'm very sorry. Non-real calculations. This is the scenario you got no real solutions. In other words, you got one of those floaters. Never going to touch the x-axis, okay? And when you talk about non-real solutions, you're thinking about, I don't even know what that means. What do you mean, fake numbers? Yes, we're going to learn about our fake numbers when we come back from Christmas.
There's fake numbers.
They're called imaginary.
Really?
I figured I would wait until we came back from Christmas. That'll be our first unit back from Christmas. That'll be the only thing we do in that unit is imaginary numbers. And then we will move on past that. Last scenario. A, B, C. I make a big joke about it with my Algebra 1s when I talk about it. Like what? Like, because we talk about real, it's a real number or something. I'm like what? There's fake numbers or something? What's that supposed to mean? But I don't tell them.
4, negative 12, and 9.
So I got something squared minus 4 something something. Once again, I'm going to plug in my B value, my A, and my C. Negative 12 squared is, anybody know? 144. Negative 4 times 4 is
16.
negative 16 times 9, a big number. And that would be?
That's 144, I think.
Like,
It is.
never mind. Never mind. I understand. Never
So 144 minus 144 is
0.
the last scenario we have.
Who would have guessed it?
So let's see, we've got the one that floats, we've got the one that crosses twice. How many solutions do you think you're going to get when it equals 0?
Maybe 1.
You're going to get 1.
Because if there's 0, then that means it comes on 0.
It's not going to be at the origin. That's not necessarily a true thing.
It's going to be.
It means the vertex is going to sit on the x-axis. We okay with that? Let's try. So based upon your mingles, I picked a standard form out of there. I ended up with a negative 3x squared plus 4x plus 3. Based on that, you've also got your quadratic formula already written out. So I'm going to take my b value of 4 and plug it in. Plug in your a value of negative 3. And then your c is 3.
Are you like looking somewhere to get these numbers? Or
Right there.
Did you just
A, B, C.
Yeah.
I just wrote it down because I tricked them. That was the first thing I said. I just picked 3 from your discriminant mingle and came up with that one. Okay.
I mean, you can't get much more random than that.
So we got A equals negative 3, B equals 4, C equals 3. We're all good? We're all caught up?
Yes.
Okay, just making sure. Okay, so then if I started simplifying, this negative 4 is just going to be negative 4 plus or minus. What's all this stuff in here going to be? 4 squared, 16. Do you agree?
Yeah.
Negative 4 times negative 3 is 12. 12 times 3. So I got plus 36. 12 and or 16 and 36.
52, I think.
52. And then on bottom, I got 2 and negative 3, which is,
-6.
okay. So now let's think about doing a little simplifying. And let's see if we can. Based upon this discriminant in here being positive, we know we're going to have 2 solutions, correct? So I'll show you where those 2 solutions are in just a second. Plus or minus, let's think about 52. Will 2 go into 52?
Yes.
How many times?
We'll say 26 times.
Okay. So then I'd have to do, and you could do this off the side instead of rewriting all this. So 52, we would say, I'm going to write it off the side. 2 times 26. What about 26? Will 2 go into that since it's even?
13 times.
Okay. So there's my pair of buddies. Do you agree?
Yeah.
Okay, so I'm going to do just a little erasing right here. My buddies come out. My 13 has to stay inside and clean house.
Wait, do we write that? Do we erase what we wrote?
No, you can write it. There wasn't any point in having to rewrite all that stuff over and over again just to simplify the inside. This almost looks like we're done, but not quite. You want to look at these 3 numbers right here. You're not going to do anything with that radical, but if these 3 numbers will reduce, then we need to reduce those. Does 2, 4, and 6 have anything in common? 2. So negative 4 divided by 2 would be negative 2. 2 divided by 2 would be 1, so I'm just going to put the square root of 13. Negative 6 divided by 2 would be negative 3. Do you see 2 answers?
That looks funny. Can't really do anything after that.
Yeah, but there's supposed to be 2 answers.
-2.
No, I see one answer.
Okay, so let me show you where they are. Negative 2 plus the square root of 13 over negative 3. Negative 2 minus the square root of 13
Oh, I got you.
over negative 3.
Do you think drawing out makes sense look stupid?
No, absolutely not. I simply want to make sure that you understand where these magical 2 things coming from, because there's only one thing there.
So are you
That
just saying
plus
that
or
just 'cause we're
minus.
recording?
No, I'm being serious. Nobody ever automatically sees that. That's why I asked. I'm always curious, does somebody see it?
I was trying to be smart with you because there's only like one physical like.
Yes, there's
Equation,
one
so I was
club
like-
there, so it doesn't look like there's 2 answers. But when I take that plus or minus and I separate them out, now you can see the 2 answers, correct? You can't even put plus or minus into your calculator to get it to give you the answer. Okay, these are called exact answers. Why? What's an unexact answer?
What's?
Such a good question, isn't it?
It is.
I
These are exact answers.
Okay.
So what would be an unexact answer? What would be an example of that?
If you just leave it.
If you just what?
If you just leave it.
Okay, let's figure out what the unexact answer is. Are you ready in your handy dandy calculator?
I have 2.
Put parenthesis.
I'll be on the graph or.
You can just be on a calculator. Parenthesis. Negative 2 plus square root of 13, close parenthesis, divided by negative 3. Those would be all the keys you type. I just wrote down what you're going to type in your calculator. Then push enter. This would be an exact answer, and your calculator just gave you a really ugly answer, didn't it?
Yes.
You would have to take that and round, wouldn't you? Which means you would approximate the answer. Is an approximate answer the exact answer? No. So this would be an exact answer that your calculator cannot give you. Your calculator can only give you the approximate, therefore, thus you're going to use quadratic formula. Okay? So, you have a sheet of paper. How do you know when to use the quadratic formula? You don't have a sheet of paper. I have your sheet of paper. How do you know when to use the quadratic formula? Here's your first problem. It goes x squared plus 4x plus 3 equals 0. Okay?
Alright.
If I were just given this, my first instinct would be to factor it. Now, because I've done this for so long, I really already kind of know what it is. But y'all would be doing, okay, 1 times 3 is 3, right? 4 goes on the bottom. 2 numbers that multiply to give me 3, combine to give me 4. 1 and 3. So that means I do x squared plus x plus 3x plus 3. Because I was able to find those two numbers, this will factor, I don't have to use the quadratic formula. If you cannot, do you remember last time when you had that one, we couldn't find the numbers? If you cannot find the numbers, it's quadratic formula time. Okie doke? Make sense? That being said, when you look at your answers on the back, you're going to see some that have the radical. That means they go with the ones that you can't factor. The other ones that are pretty, those are factorable. Okay? You don't have to just automatically use the quadratic formula on this. I'm not going to tell you which are which. That's up to you. So if you want practice with factoring, hey, take advantage of it. If not, use the quadratic formula on all of them because the quadratic formula will always work.